shape of the ground or what?
Yeah, sure.
Awesome.
Possum?
Right on. Oh, I mean, I'll try to do the Earth's not flat. Let's do that one.
Yeah. Yeah, let's
Cool.
do it.
Yeah, let's go over gas pressure real quick.
Great.
You ready?
Yep.
All right. Yo, does a gas pressure need a container or no?
Obviously not.
Okay. Can you give me an example?
Sure, the Earth's atmosphere.
Without using the thing in questioning as reference.
Can't hear you.
Without using the thing in questioning as reference, can you give me an example?
Sure, the Martian atmosphere.
The Martian atmosphere.
Yeah. The Venusian atmosphere. Jupiter.
Okay, so Peter, right?
No,
you're
but
still using the
go
thing
ahead.
You're still using the thing in questioning as reference to prove your point.
I'm not.
Earth or space, which would that's the argument. You got to prove that.
Sure, the Venusian atmosphere.
Is that in space?
Is Earth in space?
That's my entire point. It is, right?
I can still barely hear you.
I'm saying that's my point. Earth's in space, right? In your paradigm.
Yeah.
That's
So
what-
then
that's
so
not
then
an
any
element.
example would be in space. So therefore you've set out a burden that you have defined as being impossible to establish.
Okay,
There's nothing that isn't in space.
All right, cool. Let's start with the beginning. Are you a science denier, Peterson?
No.
All right, cool. Do gas particles move in random motion?
In a random motion. I don't know if I would exactly say random, because when they make collisions, whatever direction they're going to deflect in, I think that's probably predictable.
No. So yeah, gas particles move in random motion according to kinetic theory of gas particles, the equiportion theorem, Brownian gas motion, gas pressure definition, your NCHA.
I'm
So
aware of
they're moving-
Brownian motion, but Brownian motion doesn't have to do with gases. You could say
No, it's not.
fluids maybe, but
Nope, fluids and gases move the same according to Brownian motion. No,
okay.
you can, all I'm saying is this: gas particles move random motion. So for you to say no, that's just crazy. But if according to the paradigm, if that's true, I would ask, what's the container for your gas particles? What would you say?
there's no pressure is what happens when a gas exerts a force against something.
So what's the exerting its force on according to your paradigm?
Gas, it could exert its pressure on anything. It's exerting it on me right now.
Yo, you're trolling. What's the container for your gas pressure?
There doesn't need to be a container. All the gas has to do is strike some object, like me right now.
So if gas particles move in random motion, right, that means they have no biased direction for down.
What's the container of the ocean?
Is that correct?
No, Free. What's the container of the ocean?
I would personally have to say the ice wall.
What's containing it on top?
What do you mean by on top? The firmament? What do you mean by on top?
I'm talking about the oceans. What is containing the oceans on top?
That makes no sense. I just told you the container.
I know it doesn't, but I still need you to answer.
Antarctica is the container for the oceans.
I'm talking about what is containing it on top.
What's containing the water on top?
Yes.
Out of your mind? The wall.
The wall is not on top of the oceans. So what is containing the water on top?
This is embarrassing, Peter. Come on, man.
What is containing the water on top?
Yeah, there's no water on top.
So there's nothing containing it on top?
Yeah, if I have a glass of water...
Is there such thing as water pressure?
Yes, there is.
Is water a fluid?
Yes.
So in order for a fluid to exert a pressure, there does not need to be a top container.
Is your fluid in a vacuum? Excuse you, sir. You think that you live right next to a open vacuum? Remember that? Did you forget that part, Mr.
No, I
Peterson?
know I did.
Cool. So the gas particles have no
Do.
bias, they have zero bias direction for down. Then I'm asking you, what's the container for these gas particles? What are they colliding with?
Anything that is in their vicinity, like me,
So
for example, or a tree, or a
okay,
building, or the ground,
so
or
what's
another air particle,
so what's keeping them from escaping into the empty
gravity.
vacuum? Cool. So what does gravity do to them?
It drags them. I don't know if drag is the right word, but it attracts them. It accelerates them toward the surface of the earth.
Yeah, you just got cooked. Now you're a science nerd. Now you're giving him a biased direction for down with gravity. Thanks for playing Planet Peterson.
So if you're going to describe
You
the,
suck ass, dog. You're still ass at this, Peter.
oh no,
You're a
do you know what
science
a do you know what a random do you know what a random walk is?
Oh my gosh.
Free,
Yeah,
do
go
you
ahead,
know
go ahead.
Free, do you know what a random walk is?
A random walk?
Yeah.
A random walk. No, I don't think I've heard of a random walk.
Okay, it's this principle in physics. You can actually mimic it with a four-sided dice, but an object can traverse in a completely random. It can have like its path can be dictated completely randomly, but it still ends up taking a path somewhere. This is how photons escape the core of the sun, for example. But just because the gas particles, like their motion, whatever, is random, doesn't mean that an external force like gravity can't also influence their motion. They're
That's
not
my
the exact
question.
same thing, but
That's
randomness
why.
and a biased direction are not mutually exclusive.
Stop reading shit online, Peter. And second of all, your
I'm
ass at
literally
this.
just looking at my own
Kinetic.
face on the TikTok studio
Buddy,
thing.
I'm gonna give you a fun fact. Even if I granted you gravity, right? If you look up the escape velocity needed to surpass the GPE field of gravity's inertia rate, it would need to surpass 11,300 feet per second.
Holy shit, chat. It doesn't know how escape velocity works.
Oh no! First of all, I do. What the hell are you talking about? I use Maxwell's distribution to calculate the kinetic energy based off of its average temperature of the gas particle, and then with that, you
Okay,
can
free. So let's
calculate.
say we built a space elevator that goes all the way to the
I'm
moon.
trying to
Are you with
teach you
me
your
so
road
far?
religion. Why are
You
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 interrupting?
can't you can't
I'm
because you
trying
don't
to
know it.
teach you your fucking science. Stop
I know it.
interrupting.
I know how escape velocity works. You
No, the
don't.
fuck
You
you do
think that
not.
something has to be going at that speed in order
Hey,
to
one second.
escape the Earth's gravity,
Here,
and that's a incomplete and incorrect understanding of how it works. So I'm going to teach you.
no,
Let's say
I'm
we
gonna
have a
teach
space
you.
elevator that goes all the way to the moon. Are you with me so
Hold
far?
on. $20 says you don't even know the gas pressure formula, you potato. All right. So relax, Peter. Second of all, I'm trying to teach you the
Free.
difference
Let's say
between
we
the
have a
gas.
space elevator that goes to the moon. You with me so far?
Why do I gotta spoon feed you this shit? I'm trying to teach it to
I'm
you.
not going to spoon with you, okay? I'm married.
Hey, do you
What
know
if
what
we
book?
had a space elevator that went to the moon?
How do you
Are you with
calculate
me
it since
so
you know
far?
it? If you know how to do it, calculate it right now. Teach me,
Free.
man.
Let's imagine that we have a space elevator and it goes all the way to the moon. Are you with me so far?
Sure, but you're pivoting.
Okay. How fast would the space elevator have to go in order to be able to go to the moon?
How fast?
You know what? That's actually
Not
not
that
a
fast.
great
That
question. Let me ask the question in a different way.
makes no sense.
If the space elevator only went 1 mile an hour, could it eventually go to the moon?
Hey, please send me this part of me cooking you, man, after I'm done cooking you again, okay? But sure, yeah. You can go to Space Israel, sure.
That's not the question I asked. If the space elevator could only go at 1 mile an hour, could the elevator eventually go to the moon?
Obviously, yeah.
But you just said in order to escape, it has to go 11 kilometers per second.
First of all, I said in order to surpass the GPE, you don't even know what the fuck the GPE stands for, all right? It needs to surpass a
Gravitational potential energy.
It needs to surpass. Bro, stop googling shit, Peter.
I'm literally,
Oh
I'm,
my
I'm,
God,
I am
love
not
this
for,
dude.
I'm not spooning with you. I'm not gooning right now. I'm not doing any of that stuff. I've literally been playing with this little piece of plastic in my hands, and I can't really show you my computer, but I don't have any Google up. Okay, so
Surpass you, Peter. I'm the alpha now, bud. You know that?
No, I can also barely hear you again. So, anyways, you said something has to go 11 kilometers per second in order to escape Earth. That's not true. The way escape velocity works is its instantaneous acceleration, or its initial acceleration, initial velocity actually, would have to be that in order for it to go up but never come down. So you don't need, I don't know why exactly you brought this up. You were going to say like, oh, did you know that the atmosphere is like slowly escaping or whatever? Like, we acknowledge that. But no, it doesn't have to go at 11 kilometers. What you're going to try to say is, oh, is the atmosphere moving at 11 kilometers per second? Because that's the only way it can leave the Earth. No, that's not how it works. If you just maintain a steady velocity, you can escape the Earth's gravitational pull.
One more time. Listen to this, Peter. Gas particles are constantly moving, Peter. Now, they get this energy through kinetic energy, which is restricted based off the temperature of the atmosphere. Now, you can use Boltzmann's distribution. You can use Boltzmann's constant to measure the acceleration rate from the kinetic energy over the GPE field. Now, within that taken to consideration, you can measure the newtons that act on the body of mass perpendicular to gravity. And you can measure that resistance force to the kinetic energy of the gas particle. And for its individual oxygen molecule, it surpasses the GPE.
Are you one of those finger readers? Are you one of those kids that when they popcorn read to you, you got all sweaty because you read like this? You can only read the words if your finger is under the word. Because I can hear you doing that right now.
I'm not reading.
You're one of those able-sighted braille readers. You're a finger reader, but you can actually see.
I'm literally in the. All right. First of all, I've studied this. You don't study this shit, all right? Relax, Peter. All right, and second of all, I already done it. You end up surpassing it 10,000 times. The kinetic energy from a single oxygen molecule surpasses the GPE 10,000 times stronger. So even if gravity is real, you know what I'm saying? It just sucks because it's not changing the direction of a gas particle's propagation. So suck it. You got shit on again, Peter. Do you want to talk about anything else?
He wants to spoon me. He's talking about gooning. He wants to take a dump on my chest.
Peter,
I don't know. Chat, what is it doing?
Peter, you've gotten so bad at this, bro. I've surpassed you. You're like under me, like I'd say 20% now. Like, it's bad, man. You gotta Google everything. You don't even come prepared. You're trying to talk about GPE. You don't understand Maxwell's distribution or constant. It's sad, man. And on top of that, if you want, we can talk about the curvature, which you don't have, which you lack, which you would need to necessitate a convexity.
Did you know you're the only flat earther that says that water doesn't find its level because you think the water in Lake Michigan in the east is higher than it is in the west? Do you remember that? That was one of the wildest things ever.
First of all, if you look at the topography graph, you dickhead, right? You can see the different elevation. There's not the
on
same
land, yeah, but not in the water.
Obviously, what do you think the lake Michigan's on? Do you think it's on the water or on land?
You're talking about the land above the level of the lake. So,
all right, man.
Like, you literally said you said Lake Michigan is higher elevation in the east than the west. The lake, free, not the land, the lake. The lake is at the same elevation everywhere.
This is just personal incredulity, self-dogma.
Can't hear you, little bro. Too quiet.
Yeah, so real quick, man, does the ground spin underneath the hot air balloon, or do you got to Google that too?
The hot air balloon moves with the motion of the ground.
Okay.
Unless air makes it move a different direction. You know, for the same reason, I don't know if you've ever been in a bus. You don't seem like the kind of guy that can afford a car, so I assume you take public transportation. But if that bus is moving forward, you can walk to the back of the bus. You can do that, free. That is possible. So the motion is relative.
Welcome to Flat Earth, you dingus. You just debunked Coriolis. You said the ground spins with the balloon, you fucking cupcake. You don't know your own globe religion, and it's embarrassing.
Why does the Coriolis effect happen?
I'm 22 years old, bro. You don't know shit, and you've done this for years.
Why does the Coriolis effect happen?
Yes, it's the apparent deflection due to Earth's rotation causing things to spin the opposite direction according to
so you agree that the Earth is rotating. Okay, what do you want to talk about next?
I know the definition. I know your religion better than you.
I asked you what causes it, and you said
What
the
about
rotation
airplane?
of the Earth.
Let's try an airplane. Is the ground
No,
speed
we're
of an
going to
airplane?
stick on the Coriolis effect until you give up.
Oh,
What
you're
causes the
mad.
Coriolis effect?
According to your globe
No,
paradigm,
according to you.
rotation. I don't think there is a Coriolis.
Use both of your brain cells and try
I
to
don't think there is
emanate some
Coriolis.
thoughts and see if they can escape the forest of your fucking ramen noodle pube hair and
Here
get
comes
out
the
into the
homonyms. Here
microphone.
comes the
Okay?
homonyms.
Yes,
Here
I'm
comes the
humming all over your
homonyms.
nom,
He
bro.
lost.
So,
He lost. He
what
lost the debate.
causes the
Ow.
Coriolis effect? Use both your brain cells to try to tell me.
Intellectual aptitude is not a recursion for redirection. But nice try, buddy. It's embarrassing. You don't know your own globe paradigm.
Explain what causes the Coriolis effect.
Yeah, I already told you 4 freaking times, bud. According to your paradigm, it's
I didn't ask according to the globe religion. You say the globe religion is false.
I don't
So
believe in Coriolis. Why the hell would I tell you what it is? That makes no sense.
So you disagree that ocean currents in the northern hemisphere circulate clockwise and in the southern hemisphere they circulate counterclockwise. You reject that?
First of all, that's not the definition of Coriolis, dipshit.
It's an effect of the Coriolis effect.
No, that's not the definition of Coriolis. You can get that with a magnetic field if you put a negative and a positive in the center of a whirlpool. That's easy and simply explained. That's not.
So your explanation for the Coriolis effect that we observe is that there is a positive and a negative magnet in the middle of a whirlpool.
Yeah, I'm pretty sure. Yeah, there'll be the polar north will be the north. I would say the North Star Polaris would be your polar north.
Oh, jeez.
I mean, I don't know why you're saying, oh, geez. I can actually replicate this. Can you replicate it with your gravity?
Wait, are you saying there's a South Pole?
Am I saying there's a South Pole? I mean, somewhere would there have to be, yes.
So if north is the positive, where's the negative?
I'd have to say it's, I don't know, somewhere in Earth.
It's in the Earth?
I'm not sure. If you look at a magnetic.
So you have no idea. Okay.
Well, it's complicated. First of all, relax.
It's actually not. If the Earth is a globe and it spins and it has a different angular velocity at each point, but momentum is conserved. So when air currents go from the equator to higher latitudes, they're deflected because they preserve their momentum. That's what causes the clockwise deflection in the north and counterclockwise in the south.
Yeah, I'm sure.
It's actually very simple.
I'm sure. Yeah, I'm sure that's.
I teach this to 9th graders, and well, I used to, and they all understand it pretty well.
Yeah. Well, unfortunately for you, man, that sucks because you can't reproduce it through the scientific method. So you can just go keep teaching the 9th graders because that's all you got to do, man. That's boring.
What do you do?
Hey, what's the independent
variable? What do you do?
For your experiment? Go ahead, run it through me real quick.
The reason I'm about to win this debate you're going to watch is because I literally wrote the book on how to do that. Rational Answers to Stupid Questions tackles about 100 of the most common anti-scientific tropes we hear all the time. If you want to be well equipped to tackle stupidity and also learn the history and research behind the facts, you can get a copy by going to the link below. Thank you.
Run your scientific experiment to prove this. What's the independent variable for that experiment?
You don't need an independent variable to collect scientific information.
Shit. Now we don't need a scientific independent variable through the scientific method, which means you don't know the scientific method, which means you're a schmuck. You're defending.
You're conflating the scientific method with an experiment.
Yeah, what's the well? Hold on. If you want to conduct an experiment, what are the constituent parts? Right, you need an independent, dependent, and constant.
You can collect scientific information absent an experiment.
What are you manipulating to prove the cause?
It's not if you're not doing an experiment, then you're not manipulating variables. You're making observations. It's still in the purview of scientific inquiry.
If that's just an observation, you can't make a claim it's due to Earth's rotation. You cupcake. That makes no sense.
We can prove Earth's rotation through things like what's it called? It's not called a Galileo's clock, but the pendulums or whatever. They swing in different directions in different hemispheres, and on the equator, they don't deflect at all. Why is that?
This is easy, man.
Little bro, why is that?
Little bro, why
Little bro, why is that?
Why are you neglecting?
Little bro, why is that?
I don't know, buddy. I don't know. I haven't
Little
studied
bro.
the Earth.
Yeah, you don't know anything. There you
I
go.
haven't studied the magnetic field of Earth. You're right. Yeah, I don't know. I can concede to that. So, anyways, you want to prove how there's no curvature or any convexity, how things disappear bottom up according to your globe paradigm proves curvature, even though it doesn't prove curvature, or what do you want to talk about? Because you don't know shit so far.
Oh man. Hey, turn your camera on and then close your eyes and make all of your arguments. You can't do that because I heard you flipping through your papers just now.
Oh my god, I'm literally fucking.
Oh my god, he's gonna hum on my nom, everybody. Chat, he's humming on my nom.
I study this, bro. You don't know shit because you read shit. I actually
Turn your camera on and close your eyes.
I can't. This is my burner account. All my accounts got.
Oh yeah, the camera turn on thing is grayed out. So you are right. You cannot turn your camera on.
Yeah, trust me. If I did turn my camera on, it would not be good for you, bro.
What? You're a gooner?
No, I can.
You're gonna
cook you
goon
with
on
my eyes
camera?
closed. Dude, you're the easiest person to cook on TikTok, man. This is. It's too easy.
Free. If I were easy, I would be your mom. Okay.
Hey, real quick. Do planes have to count for curvature when they're flying?
No.
Really? Do they have to drop their nose?
No.
So does their pitch stay constant?
Like except during takeoff and landing.
Cool. So besides takeoff and landing, it stays constant.
Yeah, because they're constantly accelerating toward the ground, which means as they move over the surface of the Earth, as long as they're maintaining altitude, they are traveling along with the curvature of the Earth.
But the pitch stays constant, correct?
Yeah. Did you hear anything I said?
Yeah.
The plane is
Yeah,
accelerating toward the ground.
Yeah, welcome to Flat Earth. You're a schmuck. You don't understand anything about aerodynamics at all.
Is an airplane accelerating toward the ground when it's flying?
Real quick, let's take the radius of 3959.
Yeah, we're actually, of all the things we're going to do, that's the one thing we're not going to do. We'll start with hovering. When a helicopter is hovering, is it accelerating toward the ground?
Why are you scared?
When a helicopter is hovering, is it accelerating toward the ground?
No, that makes no sense.
Okay, so do you agree that for every action, there's an equal and opposite reaction?
Obviously, yeah.
Do the helicopter's propellers produce a downward thrust?
No, it creates an upward thrust. That makes no sense.
The propellers are creating a downward thrust. The acceleration of the helicopter is upward.
Yes, when you're talking about acceleration, are you not?
Okay, so we'll say it this way. When a helicopter is hovering, it is still accelerating upward, right?
Wait, what the hell? How is this even analogous to what we're talking about?
I'll feed you, little bird. All right, we're getting there.
Oh my god. Dude, what are you talking about, guy?
Okay, so when a helicopter is hovering, is there a balance of forces?
Sure. Dude,
Okay,
Peter,
what is the force that is making the helicopter attempt to go back down to the ground?
Buoyancy? I don't know. Everything seeks its equilibrium based off of its density gradient. I don't know.
Well, that's just...
Peter, I asked you, does an airplane have to count for curvature? You said
Yeah, and
no.
I'm explaining to you that it doesn't need to because that's how flying works. So when a helicopter is hovering, it is balancing forces. It is accelerating upward while a downward accelerating force is acting on it, and they're balanced. When a plane is flying, it is balancing both forces. And so as the surface of the Earth curves away, because the plane is in balance, it naturally follows the curvature of the Earth.
Cool. So does the pitch stay constant?
Yes, just like in a helicopter, as it hovers, it stays parallel to the ground as well.
All right, here, let me help you out. Since you're drowning, don't worry. If you fall off your globe, I will catch you time after time. Ready, Mr. Peterson? If the radius is 3959 and the circumference is 24901, that gives you a drop rate and altitude from Polaris 69.1 miles of curvature per degree, which means within an average
69 per one, fucking
That's
finger
one.
reader.
An average commercial airline is going 500 miles per hour. You have to count for curvature about 1.2 degrees per hour every 720 seconds. You'd have to count for curvature, Mr. Peterson. If your pitch stays constant, your gyroscope doesn't end up upside down, then welcome to fucking flat Earth, you potato. It's not my fault that you're geometrically illiterate. I have to teach a 40-year-old with gray hair. I'm 22 and it's embarrassing.
I'm not 40, I'm 34.
How many fucking times do I have to come up here and teach you, Planet Peterson? I literally made you my girlfriend every single time, and then you make the dumbest clips.
See, he's talking about spooning me, taking a dump on my chest, and now he wants to date me.
No, genuinely speaking though, 7.2 degrees a commercial airliner will have to count for in 2 hours from going with according to your radius. That's
Free,
7.2 degrees.
you
That's
should buy my book.
4,000.
It'll make you. You might grow one more brain cell. You would increase the number of brain cells you have by 50%.
See, this is the problem.
Anyways, I've done the math on this.
Don't get mad, Peter.
Yeah, stay on mute, Ramen Noodlehead.
You, Peter.
For every 10 kilometers of distance, the Earth curves 7.85 meters. Do we agree?
According to your radius, sure.
Okay. Commercial airplanes travel at about 950 kilometers per hour. Do we agree?
Let's do miles per hour. Let's do miles per hour, not kilometers.
It's the same thing.
No, we're there to go about 500 miles per hour.
So at that rate, it takes a plane only 38 seconds to travel 10 kilometers, which would be 6.2 miles, right?
Yeah, so I'm gonna do MPHs in miles, not kilometers. I'm not in fucking Canada, all right?
So this works out to or anywhere else in the world.
Yeah, that's 7.2 degrees per hour going 500 miles per hour of curvature, which is 44,000 feet of curvature you have to count for in 2 hours to flight, which you said you don't have to because your pitch stays constant. Welcome to flat Earth, you dipshit. This shit's so boring. All right, I'm out of here, Peter.
So anyways, what this works out to is an average loss of 1 meter of altitude every 4.84 seconds. Now, a meter is almost a yard. You can handle that, right?
Okay, Peter, how many times do I have to tell you?
So the airplane, 0. So the airplane is losing about a yard about every 5 seconds to maintain its steady altitude. That might sound like a lot, but we have to remember that the forces are balanced. So at this rate of 7.85 meters of curvature every 10 kilometers, do you know what the angle after the airplane has traveled 6 miles, do you know what the angle is?
Angle of what? The angle of the pitch?
From wherever the plane currently is. Well, it's actually, we could do the ground or where the airplane is. So over a distance of 6 miles, the airplane is going to, quote unquote, the curvature or the drop in altitude, whatever, is going to be about 8 meters. That comes out to a downward angle of 0.045 degrees.
Yeah, cool. That's cute.
So does that sound like a constant nosedive to you? Does an angle of less than 1/2 of 1/10 of 1 degree sound like something that the airplane instrumentation is going to be flashing in red lights?
Are you fucking?
Does an angle of less than 1/2 of 1/10 of 1 degree sound like the kind of thing that the airplane instrumentation is going to flash in red lights at the pilot?
Let me answer. Hello. All right, real quick. All right.
Oh, you're not answering. So the question is, does an angle of less than 1/2 of 1/10 of 1 degree sound like the kind of thing that the airplane instrumentation is going to be flashing at the pilot?
1 second, buddy.
Okay, I gave you 1 second, so now I'm going to have to ask the question again. Does an angle of less than 1/2 of 1/10 of 1 degree sound like something that the airplane instrumentation is going to be flashing to the pilot?
Hey, Peter, do you have a globe model?
Yeah, so the question is, does an angle of less than 1/2 of 1/10 of 1 degree sound like the kind of thing that the airplane instrumentation is going to show to the pilot?
That's exactly what the fuck it would show. So do me a favor. Do you have a globe model at your house you could bring real quick?
I have a globe.
Yeah, can I see your globe real quick? Just for demonstration. For 5 seconds. I want you to do one thing on your globe. I did it to my other glober friends. I can't do it. Why?
Because you're powerless here.
Are you scared? Are you scared of me, Peter? You're scared of a 22-year-old ramen hair dude, really?
You said you were 22.
Yeah, I am 22. You're scared of me?
You just said 23. Chat, it doesn't know how old it is.
I've never said
Chat,
23.
it forgot how old it is.
Peter, get your globe if you're not
Chat,
scared.
it just said it's 23 years old. It doesn't know how old it is.
Peter's saying get your globe if
Chat, why did it say it's 23?
All right, he's scared, chat. Hey, chat, he's so scared of me. It's embarrassing.
Chat, why did it say 23?
Dude, your chat's literally as brainless as you are, bro. It's embarrassing, bro. Can you do me a favor and please get the globe?
Chat, why did it say it's 23 years old?
Okay, so you're not gonna get a globe here. I'll tell you for you. Hey, Peter, if you had your pointer finger on the globe and your thumbprint as reference of pitch, and you wanted to go from the North Pole to the South Pole, can you do that without changing the pitch from your nose from the north to the south?
Like literally, I already explained this with the helicopter and with the airplane. When it balances forces, it's always parallel to the ground.
Okay. Cool, really? So it's parallel to the ground, right?
Free. Why did it say that it's 23?
One more time. Hello, stop.
Well, I answered your question, and now you don't get to ask another question until you answer mine.
Peter,
So I
this is the
answered
part
your
where you start
question.
running like
Now
a
you're going to
girl.
answer my question. Why did it say it's 23?
I'm not 23, you cupcake. I'm born 2003, April 2nd.
I didn't ask how old you are. I asked why did
so real
it
quick,
say that
Peter.
it is 23? Why did it say that?
Why are you running from me?
Free, why did it say that?
All right. Well, I'm out. Your brain's starting to shut down. Like,
Go ahead. Chat, why isn't it leaving?
Peter.
Chat, it said it's 23 and it said it's leaving, but it's neither of those things apparently are
Just
true.
so you know, I made you my freaking girlfriend in this debate, bro. You are actual dog shit at debating. Dog shit, Peter. Remember that when you go to sleep. Free kicked my ass in this debate, and I have a bunch of Glober donuts trying to pretend that I'm smart. Okay? That's all you, brother. I love you. You would have had to account for 7.2 degrees of curvature.
Gross.